Hello, everyone. This is Dr. Lennon, and I thought we'd just go over a handful of the homework questions for homework number 2. So again, this is on the truth tables involving things like um, contrapositive and converse and things like that. For some of these things, the first one's what is the negation of a proposition? Make up an example of a proposition that's negation. Again, these things are basically just found in the textbook or through the PowerPoint lecture that we went through. So you can navigate to the textbook just using this bar, and if we want to find negation, we can go ahead and do that, which we already talked about in the lecture, but I just want to go through to show you how to find these type of things. So it's going to be in Unit 1B, and we just want to look for, we see right there, negation. So the logical opposite of a proposition is called its negation. You can also search using this, so we could search for negation. You can also use Control F and just search to see if it appears anywhere on the page. And I don't know why it's not appearing, because clearly we can see it right here. Negation. Let's see if there's another way to do it here. Typically, you should be able to search. I don't know why. It doesn't look like it's working for me right now, but typically it should be. Anyway, we found it right here. The logical opposite of a proposition is called its negation. So for any of the definition style ones, you can go ahead and do that. I'm sorry, I got the wrong one. So we have the homework here. If P is a propagation, the negation of P is not P, the logical opposite. If P is true, the negation of P is false. And if P is false, the negation of P is true. And we have that one. So give an example of a proposition and its negation. The product of two negative numbers is a positive number. The negation would be the product of two negative numbers is not a positive number. So that would be is that the logical opposite? The only problem here is it doesn't include 0, so does that matter? I don't think so. This is true and this is always false. So that should be, let's just look at the other options. The product of two negative numbers is a negative number. The product of two positives, no, that's not the logical opposite because the product of two positives is positive. So first statement is true and the next statement is also true. C, the product of two positive numbers is a positive. The product of two positive numbers is not a negative. Well, that's not strictly false. It is false in the case of 0, but all other cases it would be true. The product of two negative numbers is a positive. The product of two positives is a negative. So let's see. The one thing here is this is always two. The product of two negatives is always a positive. This shouldn't be the negation because it's talking about something different. Yeah. So I'm going to go with A here. All right. And then, again, this is just another definition one, so you can look that up. Let's see if we can find something a little more interesting to go through. The following statement makes sense or does not make sense. Explain your reasoning. So again, this may come up to our list of logical fallacies. We may have to look those up. So let's go through each one. The statement, here's the statement. We intend to catch him dead or alive. So the statement makes sense because when the man is referred to as being caught, he must be either alive or dead. The statement does not make sense. Well, the statement should make sense. It seems logical to me. So we'd be between A and D. The statement makes sense because the man the statement is referring to will be caught. Yeah, so I would say A here. B does not make sense. He could be neither dead nor alive. Well, that doesn't make sense. You have to be one or the other. And it does not make sense because he might not ever be caught. Well, it doesn't say he's going to be caught. It says we intend to catch him. So that should be A. Okay, so that's all we had there. We get another typical similar question with 4. Let's go ahead and see if 5 is something different. Determine if the following statement is a proposition and give an explanation. Who wants another piece of cake? This is a question, so it's not making any claims, so it's not going to be a proposition. So in this case, that would be B. Again, many of these are refer to directly things we've talked about in the lecture video. So let's look at 6 real quick. Write the negation and then state the truth value. May does not come before April. That is true. So the negation should therefore be false. What would the negation be? Well, it would be the opposite, the logical opposite, which would say May comes before April. So May does come before April would be the opposite. And then the truth value of the given proposition, the one we started with, is true. And the negation, therefore, is false. Okay, so that's that question. Let's look ahead a bit. Okay, so we've got a conjunction here. We've got the and statement. And we want to determine if the statement is probably true or false. Remember, for an and statement to be true, then we have to have both statements being true. 10 plus 9 is 19, and 3 times 4 is 12. So this is going to be true. Let's not go through all the parts of it. Let's maybe do one that's a little more interesting. Here's an or statement. State whether or is used in the inclusive or exclusive sense in the following preposition. I live in town A or town B. Well, in logic, we said it's always going to be the inclusive, but this sounds like a language thing, so I would guess this would be exclusive. You either live in town A or you live in town B. Again, that's a language type setting, not a logic type setting. Again, let's just look ahead further. Here's another similar type question. Let's keep going. Here's just computing a truth value of R or. This we've completely done in the lecture, so just refer to the lecture and you should be able to find that. So moving ahead. Again, completing a truth table, we've done those in the lecture. Okay, so let's maybe look at 2 more. So identify the hypothesis and conclusion in the following proposition and state the truth values, then determine whether the entire proposition is true or false. If Hong Kong, so this is an implication. So if Hong Kong is in China, Hong Kong is now considered a part of China. I don't think it used to be. Then Tokyo is in Japan. So the hypothesis is Hong Kong is in China, which is true. The conclusion is Tokyo is in Japan, which is also true. And then we know true implies true will be true. That's the only case where we have the implication being true, right? True implies true is true. True implies false is false. Oh, no. So it's true in 3 cases and only false in 1. The only thing that is not going to be true is true implies false. So yeah, this proposition is true. Just if we go back to the notes we had in the previous section when we talked about the implication here, true implies true is true. True implies false is false. False implies true is true. And false implies false is true. So that's how we're getting the truth value of the implication there. Okay. Okay, we've got another similar type question here. Let's look at 15. If Jose has a garden, then he has seeds. Write the inverse, converse, inverse, and contrapositive. Of these 4 propositions, state which pairs are equivalent. Well, we know the original implication is always going to be equivalent to the contrapositive, and the converse and inverse will be the equivalent as well. So the converse is just the other direction. If Jose has seeds, then he has a garden. The inverse would be the contrapositive of this. If Jose does not have a garden, then he does not have seeds. And then the contrapositive is if you take this original statement and the implication and negate it, if Jose does not have seeds, it would imply that Jose does not have a garden. And again, that's just looking at the definitions of the converse, inverse, and contrapositive. Again, if you have P implies Q, the converse is Q implies P. The inverse would be not P implies not Q, and the contrapositive is not Q implies not P. So I think that's pretty much straightforward on this homework. Oh, there's more parts. Let's continue. Select all pairs that are logically equivalent. Well, we know the conditional or the implication and the contrapositive are equivalent. And we know the converse and the inverse are equivalent. And those should be the only two. Yeah. Okay, and then 16 is a question in the same vein. So that should help you at least get through most of these. And if you're having problems, again, I would recommend that you watch the lecture again or go through the PowerPoint or take a look at the notes. So this is Dr. London signing off.